Hello, my name is Vignesh Senthil Kumar. This is going to be math notes number 4, linear versus exponential growth slash decay. So first off, the types of question you'll see for like this topic would be questions like it'll give you like a graph and it'll say which out of the four is this, or it'll give you an equation, it'll say which of the four, or like a scenario, stuff like that, or it'll tell you which one it is and you need to pick the right equation or something like that. And that you'll see those types of questions in the problem set I've attached at the end. And again, while the problem set I've attached is good practice, you should always search online or go to Khan Academy or just search online for extra practice problems on this topic in order to further your knowledge on this topic to make sure you fully master it. Because like any topic on the SAT, the more you practice, the more you master it. So first off, let's just go over the basics of each of what linear growth slash decay is and exponential growth slash decay is. So first, linear growth slash decay, it's modeled by the equation y equals mx plus b, and the b value is the initial value, and then the m value is the slope. So like how much it goes up by constantly. So that's pretty simple. That's like the simple like linear equation you see like your whole life. And if the slope is positive, that indicates linear growth, and if the slope is negative, that indicates linear decay. So that's just something you should know. So that's how you can quickly determine if something's growth or decay. And below I have the graphs here for linear growth and decay. A would be linear growth and C would be linear decay, which obviously won't look exactly like this, but it'll look something like this. Well, it's a straight line going upwards or a straight line going downwards. Now we have exponential growth slash decay. This is modeled by the equation y equals ab to the x power. So the a value is the initial value, much like how b is the initial value, and the b value is the rate at which we multiply the initial value. So like if I give you an example, so let's say a number increases a rate of 10% per year, the b value is 1.10. So yeah, and say like for linear growth slash decay, if b is positive, it's exponential growth. If b is negative, it's exponential decay. And if you look at the graphs, how the graphs would sort of look like, b, if you see it, it starts off going up by a slow rate, but then it rapidly goes up. And for d, it rapidly goes down at first, and then it goes down at a slower rate. But let's do a couple questions on this topic. So I have attached 8 questions here and the answers, and I'm gonna do like 4 of them. So first off, number 1, if the initial population of rats was 20 and grew to 25 after the second year, this is supposed to be first year, by the way. I think that's a typo right there. After the first year, which of the following functions best models the population of rats p with respect to the number of years t if the population growth of rats is considered to be exponential? So right here it tells us it wants an exponential equation. So we know it can't be a and we know it can't be d. So we know it's either B or C right here, because like right here, it follows the format of y equals a times b to the x power. So, the easiest way, in my opinion, to do questions like this is to just plug in numbers and see which one gives you a p of 25. So for B, t would equal 1 because it's after the first year. Remember, it's not the second year. That was a typo. So that would be 20 times 1.25 to the 1 power. That's 1.25 times 20. That's 25. So that works. So that B is the right answer. But just to make sure, we try C. P is equal to 20 times 5 to the 1 power. That's 20 times 5, and that's 100, and that's not equal to 25. That's why C is not the right answer. This one goes like number 4. This is like a similar thing like I said before, where they gave you like a graph and they ask for you like which one is it. So this is the strongest positive association between x and y. So what that basically means is it wants what's the closest one that represents a straight linear graph. So A, I could see a linear graph from that, so I'm not gonna cross it off yet. B, it's just all over the place. I don't know if it's positive or negative or what it is, so it can't be B. C, that's a very close to a linear graph. So far but C is closer to a positive graph than A is, because A is sort of less similar to a close line. So A is not the right answer. So C so far looks like the right answer, and D, this is trending downwards. So C, which is trending upwards, seems to be the right answer. So that's why C is the right answer and D is not the right answer there. Now, number 6, this is another type of question. Albert has a large book collection. He decides to trade in 2 of his used books. 2 of his used books for 1 new book each month at a local bookstore. Which of the following best describes the relationship between time in months and the total number of books in Albert's collection? So let's just think of this in a logical way. So Albert has a large book collection. Let's say he has 10 books. I'm sure he has more, but I'm just gonna use simple numbers for the sake of it. So he has 10 books. He uses 2 of his books, so he gives in 2 of his books. So now he has 8 books. But he gets 1 new book. So now he has 9. So he lost a net loss of 1 book for each month. So if you see, it constantly goes down by 1 each year. Because first he got 9. I already know what happens. Next he loses 2 books, that's 7, but he gains 1 more book, so it's 8. So if you see, he's losing constantly 1 book per month, which is a constant decrease, which is representative of decreasing linear. That's number C. And the last one I'm going to do is number 8. Of the following scenarios, which one would result in linear growth of a square footage of a store? So you want the linear growth to go up. The owner increases the square footage by 0.75% each year. Increasing by 1% each year, that's exponential, so it can't be A. B, the owner increases the square footage by 5% each year. Again, that's increasing. Sorry, A would be decreasing. My bad. I messed that up. Wait, no, sorry. A would also be increasing. Okay, ignore what I just said. Sorry, my bad. So yeah, so A and B are all about increasing it by a percentage each year. So that's why A and B can be true. Now for C, the owner expands the store by 5% of the original square footage each year. This is the key part. It's 5% of the original square footage. So I'll explain that one later, but let's go to D. The owner alternates between adding 200 square feet 1 year and 300 the next year. You see, this is not like a it's not a linear growth. It'd be like blah blah the slope is not going to be constant. So that's why that's why D can't be the right answer. So C, let's see. You might be thinking it's a percentage. So why is that the right answer? Well, it's 5% of the original square footage. So let's say I had 100 square foot before. 5% of it would be 5. So I'm increasing by 5 each year, not by 5% of the new total, but I'm doing 5% of the original total. That's a constant number that won't change. So you're increasing by a constant rate, which is why C is the right answer there. So yeah, I hope this gives you a taste of what the exponential slash linear growth slash decay would be questions look like on the SAT. Like I said, try to keep doing more practice problems. And yeah, that's basically it. Good luck on your SAT adventure.